Good morning, everyone. Myself, P. Vanitha, working as assistant professor in the Electrical and Electronic Engineering Department in Sri Muthukumaran Institute of Technology. This course is titled Power Electronics for Renewable Energy Systems. In this course, we will study how renewable energy sources like solar and wind are converted into usable electrical power using power electronic converters. Before going into converters and machines, we must first understand the basics of renewable energy sources. That's why Unit 1 focuses on the introduction to renewable energy systems. In this course, we have 5 main objectives. First, we will learn the various types of renewable energy sources such as solar, wind, biomass, and fuel cells. Second, we will understand the electrical machines used in wind energy conversion systems. Third, we will study the principles of power converters used in solar PV systems. And fourth, we will learn the power converters used in wind energy systems. Finally, we will perform simulations related to solar PV systems, fuel cells, wind generators, and grid integration of renewable energy sources. These objectives tell us what knowledge and skills you will gain by the end of this course. You will not only study renewable energy sources theoretically, but also understand how machines and converters work with them. Simulation studies help you visualize real-time behavior of systems, which is essential for design and analysis in modern power systems. Next, this slide shows the syllabus of this course. Along with theory, this course includes simulation studies such as modeling of solar PV systems, fuel cells, induction generators, wind turbines, and grid integration of renewable energy systems. This helps you understand both the theoretical and practical aspects of renewable energy. By the end of this course, you will be able to understand renewable energy sources, analyze power electronic converters used in renewable system, and simulate renewable energy systems using software tools. These outcomes ensure that you gain both knowledge and application skills. Next, we will move on to the introduction to renewable energy systems. Now we begin Unit 1. This unit introduces the concept of renewable energy systems. We will discuss classification of energy sources, importance of renewable energy, environmental impacts of conventional energy, pollution, and a qualitative study of some renewable energy resources. This unit builds the foundation for the entire course. Without understanding why renewable energy is needed and how energy sources are classified, it is difficult to appreciate advanced topics like converters, control, and grid integration. Next, we will see the classification of energy sources based on usability. Electrical sources can be classified based on usability into primary and secondary energy sources. Primary energy sources are those available directly from nature such as coal, crude oil, sunlight, wind, running rivers, vegetarian, and radioactive materials. Secondary energy sources are obtained by converting primary energy sources. Example include electrical energy, thermal energy in the form of steam or hot water, refined fuels, and synthetic fuels like hydrogen. Primary energy is the raw form of energy obtained from nature. The secondary energy is the usable form of derived from primary energy. This classification helps us understand the energy conversion chain starting from natural resources to final energy derived, delivered to consumers. Based on traditional use, energy sources are classified as conventional and non-conventional. Conventional energy sources include fossil fuels, nuclear energy, and hydroelectric power. Non-conventional energy sources include solar energy, wind energy, biomass energy, and other renewable sources. These are gaining importance due to environmental concerns. Conventional energy sources dominated power generation for many decades. However, their environmental impact forced us to explore non-conventional sources. Non-conventional does not mean unreliable. It means newer and cleaner technologies. Based on long-term availability, energy sources are classified as non-renewable and renewable. Non-renewable energy sources such as coal, petroleum, and uranium are limited and will be exhausted one day. Renewable energy sources such as solar, wind, biomass are continuously replenished by nature. This classification is important for future planning. Renewable energy ensures energy security for future generation, whereas non-renewable energy sources will eventually be exhausted. Energy yield ratio is defined as the ratio of energy received from a raw energy source to the energy spent to obtain that source. A higher energy yield ratio indicates a better and more efficient energy source. Energy yield ratio helps us evaluate whether an energy source is worth exploiting. If the energy spent in extraction is high compared to energy obtained, the source becomes inefficient. This concept is important in economic and environmental analysis. Energy sources can also be classified based on commercial application into commercial and non-commercial energy sources. Based on origin, energy sources include fossil fuel energy, nuclear energy, hydro energy, solar energy, wind energy, biomass energy, geothermal energy, tidal energy, ocean thermal energy, and ocean wave energy. This classification shows the wide variety of energy sources available in nature. Each source has unique characteristics, advantages, and limitations. Engineers must select the appropriate source based on location, availability, and demand. Renewable energy sources are important because fossil fuels are rapidly depleting. Energy demand is increasing due to pollution, growth, and industrialization. Conventional energy sources cause pollution and environmental degradation. Large hydro projects affect wildfield and cause deforestation. Fossil fuels are also required as raw materials for chemical industries, so they must be conserved. Renewable energy sources help reduce dependency on fossil fuels. They support sustainable development by reducing pollution and conserving natural resources. This is essential to meet increasing energy demand without damaging the environment. Conventional energy sources have certain advantages. They are cheaper at present, easy to store, and convenient to use. The technology for conversion and utilization of these sources is well developed and widely available. These advantages explain why conventional energy sources are still widely used today. However, they are mainly short-term benefit and do not consider long-term environmental impacts. Despite their advantages, conventional energy sources have serious disadvantages. Fossil fuel generate pollution such as carbon monoxide, carbon dioxide, nitrogen oxide, sulfur dioxide, particulate matter, and heat. These pollution degrade the environment and cause health problems. Carbon dioxide is mainly responsible for global warming. The pollutions released from fossil fuels not only affect the environment but also human health. These effects are cumulative and long lasting, making conventional energy unsustainable in the long run. Gold is also valuable raw material for chemical and pharmaceutical industries and should be conserved. Nuclear energy has problems such as radioactive waste, accidental leakage, limited uranium availability, and the requirement of advanced technology. Large hydroelectric plants cause deforestation, ecological disturbances, and displacement of people. This slide highlights why even advanced energy sources like nuclear and hydro have limitations. Every energy source has trade-offs, which must be carefully evaluated before large-scale implementation. There is always a trade-off between energy generation and environmental protection. The major environmental aspects include ecology, greenhouse effect, global warming, pollution, and green power. Energy generation cannot be separated from environmental impact. Understanding these aspects helps engineers design systems that minimize environmental damage while meeting every energy needs. Greenhouse gases such as methane, nitrogen oxide, ozone, water vapor, CFC, and HFC trap heat in the atmosphere. This greenhouse effect maintains Earth temperature, but excess greenhouse gases increase global temperature. The greenhouse effect is a natural process, but human activities have intensified it. Understanding greenhouse gases is essential to control emissions and mitigate climate change. Carbon dioxide plays an important role in maintaining Earth's average temperature. Excess carbon dioxide emission due to fossil fuel usage has increased its concentration from 250 ppm to about 400 ppm. This has increased Earth's temperature by 0.5 to 0.5 degrees Celsius over the past 150 years. The data on carbon dioxide concentration and temperature rise clearly show the impact of human activities. This emphasizes the urgent need for renewable energy adoption. Global warming leads to melting of polar ice, rise in sea level, extreme weather conditions, changes in rainfall patterns, increased acidity of water, and damage to marine ecosystems like corals. These consequences affect ecosystems, human health, and economics. Renewable energy plays a major role in reducing these effects by lowering greenhouse gas emissions. Pollutions can be indoor or outdoor pollution is caused by traditional cooking methods, while outdoor pollution is caused by industries and vehicles. These are the indoor and outdoor pollutions. This it is causes by global warming, acid rain, and acid snow, the degradation of environment. Pollution directly affects quality of life. Identifying its sources helps in developing effective control measures and policies. To reduce pollution, we must reduce fossil fuel usage, adopt less polluting technologies, use electric vehicles and hydrogen energy. Green power generation, green power generated from solar, wind, water, and biomass is eco-friendly and helps control pollution and global warming. Green power represents a shift towards cleaner energy solutions. It not only reduces pollution but also supports sustainable and responsible energy usage. Now we move to qualitative study of renewable energy sources such as ocean energy, biomass energy, and hydrogen energy. This section introduces specific renewable energy resources. A qualitative study helps understand their basic working principle, advantages, and limitations. Ocean energy can be classified into tidal energy, wave energy, and ocean thermal energy conversion, also known as OTEC, OTEC. Ocean energy is a vast and largely untapped resource. Each type of ocean energy harnesses a different physical phenomenon of the ocean. In water, this is the outline diagram. The temperature difference between warm surface water and cold deep sea water is used to generate power. Low boiling point liquids such as ammonia or propane are used as working fluids. Water utilizes temperature difference in ocean water. Though efficiency is low, it provides continuous power, making it suitable for island regions. Water provides continuous power and uses free natural energy. However, it has low efficiency, high capital cost, and may affect marine ecosystems. This slide emphasizes the technical and environmental challenges of vortex systems, which must be addressed before large-scale deployment. Tidal energy is pollution-free and inexhaustible, but it is site-specific, expensive, and power output is variable. Tidal energy is predictable and renewable, but site limitations and high costs restrict its applications. Proper site selection is crucial. This is the outline diagram of tidal energy. Uh, to conclude this presentation, renewable energy systems play a vital role in reducing pollution and ensuring sustainable energy for the future. In the next units, we will study power electronic converters used in renewable energy applications. Thank you.